problem number 9, we have a equation that includes both y and x, where y is not a function of x, or vice versa, off the bat. So when we're asked to find the derivative like we are in part A, we need to make sure that we do this correctly, and for this we need to use implicit differentiation. So part A is asking us to find dy dx. So that means we need to find the derivative of y with respect to x, which means we need to derive this entire equation with respect to x. So essentially you're treating y as just another variable, but when you take the derivative of y with respect to x, everything you do has to be multiplied by this dy dx term, whereas any x component is just derived in the normal fashion because you're deriving with respect to x. So when you derive x's, you just use your normal derivative rules. So the first term here, 5x squared y, we're going to have to use the product rule. Because x squared and y are two different functions, they're multiplied together, we have to use the product rule to take their derivative. So I'm going to leave the 5 out of the product rule and then just multiply it in afterwards. So to start the derivative here, we'll have 5 times the product rule derivative of x squared and y. So remember that the product rule, you take the derivative of one times the other, then switch those and add them. So the derivative of x squared is just 2x, and then we multiply by the other term, which is y. Then we add, when we do that in the reverse fashion, now we have x squared, and we times the derivative of y. The derivative of y is dy dx. So this is our derivative of the first term here. So now the derivative of y cubed, we're subtracting that. So the derivative of y cubed is 3y squared, but then we have to multiply by dy dx. Again, because we're taking the derivative with respect to x, and this term is not x. On the right side of the equation, the derivative of 1 is 0, and the derivative of x squared is just 2x. So this is, in our first step, taking the derivative of each term, this is what we end up with. So now our goal in this problem is to figure out dy dx. So what we need to do here is isolate dy dx and just solve. So dy dx is just another variable here. We have x's, we have y's, we have dy dx. We're trying to get dy dx by itself. So you can see here we have 3 terms, 1, 2, 3. 5 is multiplied times both of these. So I'll leave the dy dx terms on one side and move this term over. So the left side is going to be 5x squared dy dx minus 3y squared dy dx. So that equals 2x. We have this 2x, and we're going to subtract this term over because it didn't have any dy dx in it. And this term was 10xy. Okay, so now we have an equation where the dy dx's are on the same side. So this is just how you would do any algebra equation of this form. We're going to factor out dy dx and then divide by everything else. So when you factor out dy dx, you end up with, on this side, 5x squared minus 3y squared equals the same thing over here. But what I'm going to do over here is factor what we can. 2x minus 10xy, we can factor out 2x. This would be 1 minus 5y. And finally, we divide by everything that's not dy dx. So dy dx is equal to 2x times 1 minus 5y divided by 5x squared minus 3y squared. So this is our dy dx term. So that answers part A. What is the derivative of this equation? Right here, it's necessarily in terms of both x and y because our equation was in terms of x and y with neither being a function of the other. So then in part B of this problem, we want to find the equation of the tangent line at the point 1, 2. So we know that this point 1, 2 is on this graph, and we want to find the equation of the tangent line. So to find the equation of the tangent line, all we need is a point and a slope, and we already have a point, so we just need the slope. But this dy dx gives us the slope. So what we need to do is just plug in our x and y values into this. This will give us the slope, and then we can create the line. So the slope is, if we plug in 1 for x here and 2 for y. So I'm going to do that now. So that's going to be 2 times, because our x is 1, 1 minus 5y. Now y is 2, so that's 1 minus 10. The bottom, x is 1, so this is just 5. And y is 2, so this is minus 12. When we evaluate these numbers here, we get 2 times negative 9, which would be negative 18. On the denominator, we get 5 minus 12, which would be negative 7. So our slope is just 18 over 7. So we had negative on both the numerator and denominator. So now we have our slope and our point, and we can make a line by using either point slope formula or just y equals mx plus b, which I'm going to use here. So we know this is the equation of a straight line, and we know 3 pieces of this information. So I'll plug those in. We have our y is 2. Our slope is 18 over 7. Our x is 1. So I'm not going to write that there, and we know that's plus b. So we can solve for b here just by subtracting over the 18 over 7. 2 would be 14 over 7, so 14 over 7 minus 18 over 7 gives us negative 4 over 7 for b. So that tells us that the final equation of our line is going to be y equals 18 over 7x, because that's our slope, and our intercept is minus 4 over 7. So that's the equation of our line given the slope that we got from the dy dx and the point that we were given in the problem.
The Teaching Center, UF's Learning Resource Center.